Hello again, and to further continue, we are going to discuss about live data streaming and parameter measurement. In vehicle diagnostics and onboard diagnostics, live data streaming and parameter measurement are essential functions that allows technicians and diagnostic tools to monitor real-time performance data from various ECUs. So this is one channel. This is one methodology through which you can measure the real-time performance data. Okay, from various ECUs, from various sensors and actuators while the vehicle is operating. Okay, and these functions are critical for diagnosing intermediate faults, verifying sensor accuracy, evaluating engine and emissions performance, and supporting repair verification and road testing. Okay, so this supporting repair verification and road testing is extremely important, and in this particular aspect, live streaming plays a very pivotal role. What is live data streaming? Live data streaming refers to continuous real-time reading of various operating parameters from vehicle systems while the engine is running or during driving. Example, engine RPM, vehicle speed, throttle position, coolant temperature, O2 sensor voltage, etc. These are all the various parameters that can be proactively or parallelly be observed. This is typically accessed during mode $01 current powertrain diagnostic data under the SAE J1979 OBD2 standard. All right. So what is this parameter measurement? What does this involve? Parameter measurement involves the quantitative monitoring of the vehicle variables called PIDs, parameter IDs. Okay. And what is the purpose? This is meant to identify whether values are within acceptable limits, compare live readings against stored DTCs or freeze frame data, perform advanced diagnostics like fuel trim analysis or misfire direction. Okay, so these these three reasons are the reason why this quantitative monitoring of the vehicles is so important. Step by step, how live data streaming works. So we'll see how this live data streaming is carried out. First is connect the diagnostic tool, interface through OBD2 port, use compatible protocols, CAN ISO 15765, KWP 2000 or ISO 91412. Okay, establish communication. The scan tool requests list of supported PIDs using 0100, and this returns bit encoded list of available PIDs. So whatever PIDs are available in the ECU, they are immediately returned. And the tool then queries individual or multiple PIDs using mode $01. Okay, and I already explained to you what is meant by mode $01. Next is request and response cycle. Request 010C for RPM. Response is 410C 1A F8 interpreted as RPM. Okay, now when it comes to display of parameters, scan tool decodes and displays the values with labels and units. When it comes to engine RPM, 690 RPM, throttle position is 18%, fuel trim plus 3.1%, and oxygen sensor 1 voltage 0.78 volts. Okay, so these are the ways step by steps how the final display of parameters is accomplished. Now let's see the common monitored parameters, common monitors PIDs. Okay, the various PIDs are mentioned here on the left side on the table, and the parameters are RPM, vehicle speed, coolant temperature, intake air temperature, manifold air fuel sensor, uh, throttle position, OBD standards, runtime since the engine start, and when it comes to description, engine RPM means speed of the engine crankshaft, actual speed of the speed sensor, and the coolant temperature indicates indicates engine cooling status, air temperature entering in intake manifold, MAF sensor mass airflow into the in the engine, And throttle position, driver demand versus engine response. This is extremely important. Throttle position sensor plays a very important role in controlling the emissions also. Okay, so sensor plays a very important role. And when it comes to OBD standards, type of the OBD standard, whether it is OBD2 or OBD3, and runtime since the engine start, duration since last ignition. Now, when it comes to advanced live data graphing and logging, okay, modern scan tools allow graphical display of one or more parameters over time, overlay comparison of related values, example RPM versus mass airflow versus throttle. So this three parameter comparison again is extremely important. And when it comes to logging and exporting data for later analysis. All right, so these are all the live data that are simultaneously graphed and logged, or converted into graphs and also logs, so that the technician can get a clear picture of what is happening inside the vehicle. Now, when it comes to live data by various ECM domains, so there are various ECU domains, and what are all the various live data that is transmitted by the various ECU domains. For example, engine ECU, it telecasts live data, RPM, fuel trim, lambda, knock. Transmission ECU, gear position, clutch position, solenoid status. ABS ECU, wheel speeds and brake pressure. Airbag ECU, impact sensor, seat belt status. And when it comes to body ECU, door status, lighting control, window switches. The benefits of live data and parameter measurement, real-time fault analysis, pinpoint when it comes to what is the first important benefit? The important benefit is real-time fault analysis. It pinpoints erratic sensor values or failing actuators. And when it comes to repair confirmation, ensure issues have been resolved. And when it comes to drive cycle support, observe readiness, monitors. And when it comes to fuel economy diagnostics, detect MAF, mass airflow, oxygen sensor, or trim faults. So these are the various benefits. Now coming to the challenges and consideration, the biggest challenge is data latency. Okay, especially when querying too many PIDs simultaneously. So when you are querying too many PIDs simultaneously, there's a good chance that there is some kind of lag. And when it comes to PID support varies, not all ECUs or vehicles support every PID. Now, multiple ECUs. Okay, multiple ECUs live data may need to be gathered from several ECUs separately. Okay, so this poses a very important challenge, especially when you are dealing with multiple ECUs. And interpretation, it requires understanding of normal ranges of sensor behavior. This is where the efficacy or expertise of the technician comes into picture. Okay, the technician must be well versed, or he must have enough expertise to interpret the PIDs in an accurate manner. So when it comes to a real world example, for example, there is a misfire diagnostics. First symptom is check engine light plus rough idle. All right. So first step is view live data of RPM, MAF oxygen sensor, fuel trim misfire counter. Okay. So whenever you are seeing engine light, all these parameters can be immediately be monitored, and observe the RPM fluctuation and fuel trim spike on cylinder 3, and swap ignition coil, retest live data, smooth RPM, normal fuel trim. And when it comes to problem resolved and verified via live streaming. Okay, so because of live streaming, the problem is immediately resolved by taking this proactive action. So the summary, in summary, when it comes to live data streaming, it continuously monitors of real-time sensor values. And when it comes to parameter measurement, PID-based interpretation of operational values. And mode use SAE J1979 mode $01 for current data. And when it comes to tool needed, well, this is a common tool, OBD2 scan tool with live data capability. And when it comes to key benefit, it enables accurate diagnostics and repair validation. Okay, so hope all of you got the importance of live data streaming. Thank you.